Well, hello everyone. I'm back, kind of. Um, I haven't done these live streams in a while, and basically, this is where I do live coding projects, and this is a project I was working on last year, but some things came up and I had to stop the project. But I'm back now. I'm back. I try to do this every Saturday where I work on a data science project live on this YouTube channel. And like as always, if you have any questions, just let me know in the comment section below. So today's video is going to be very simple and straightforward. I'll just quickly um explore kind of like what happened here. Like I'll go ahead and do a brief overview of the overall project, and then what next thing I'm going to do is I'm going to refactor this code, so it's going to be more concise and it's going to make more sense. And the next step in this project is the next step in this project will be building a Flask app for this project. So that's going to be fun. I think I'll start that next week, building a Flask app for the project. But for this week, I'll just refactor the code and kind of get it ready. And this live stream is going to end around 12:30 p.m. So I scheduled about 2 hours for it. Let me grab a bottle of water real quick and I'll be right back. All right, so I'm back and let's see here. So this is the project we've been working on. This is predicting insurance premium and also predicting customer lifetime value. So this is the original data. Of course, I'll go ahead and run this as we go. Well, actually, I don't need to run it because I'm going to be refactoring this code. And this is the notebook that I'm going to use for the refactor. Can go ahead and close this so we have more space here. All right, and I'll probably go ahead and hide this too. It's fine, leave it. So, okay. All right, so this is the original notebook, and sometimes when I'm doing a refactor, actually most times when I'm refactoring my data science code, I usually do it in a new notebook because it's just easier to copy the code over when it's in a new notebook. So this is the data set, and this is us getting the shape of the data. And of course, this is the stuff I did last week, and this is us getting a profile report. And the reason why I commented this out is because profile report costs a whole lot of time to do. So I commented out profile report here. And then this is, I made a note for myself of things I wanted to do in this project. And this is exploring the data types. And this is us changing the date to date time. And the activation date was an object, which changes into date time. And this is us dropping columns that we don't need. And this is us splitting the data into training and test data set and validation data set. And this is also getting more descriptions about the project. And this is where we did the remapping. So this is ordinal encoding. This is where we did ordinal encoding. And of course, all of this is live streamed. I live streamed this whole project last year. And this is more ordinal encoding. So basically, when I do the refactor, I'm going to combine all this ordinal encoding code into a function to make it easier to work with. And this is more ordinal encoding stuff. Yep, this is more ordinary encoding. So we spent a whole lot of time encoding different data set, different columns. And after the encoding, this is where we change the names of the states to make it easier for us to work with. And this is when we worked on some visualizations. As you can see, this is pretty cool. This is the visualizations we worked on last time. This one is awesome. This is one of my favorite visualizations. It has a trend line with it. And this is a 3D visualization that we created. And of course, you can go back and watch all these videos. It's in the channel. And I live streamed this whole project. That was the whole thing. More visualizations, and then after we finished the visualizations, we got a baseline model. So first we started by exploring the data, then we did visualization, then we got a baseline model, and we did a linear regression model. We experimented with different models, trying to find which model is going to perform the best for this, and then we visualize the results of the model. And then after that, we did some hyperparameter tuning, and then after some hyperparameter tuning, and we decided on a final model for the insurance premium using a random forest model. We could have tried other models, but I just stuck with random forest. And this is experimenting with a gradient boosting model. And then we did a Shapley plot for this project, and this is what the Shapley plot for this project looks like. This is pretty cool. And basically it tells you that, hey, the model predicted 112 for the insurance premium, and these are the factors that played into this prediction. And if the model predicted 65, these are the factors that played into this prediction. And then we worked and then we did customer lifetime value. That's what I was looking at. Let's see. Give me a second here. So now we did the prediction for customer lifetime value, and of course we got a model. We did the encoding. Now we got the linear regression model, and then we got a little prediction, and then random forest model. And eventually we got the Shapley plot for it. Basically, if the customer lifetime value is predicted to be $5,657, these are the things that will impact that prediction. And so basically I said moving forward, these are the things we could do. We could select the top 10 features that contribute to customer lifetime value and just stick with that. So instead of working with everything, we'll just choose 10 features. And that's what I plan to do. And we can do hyperparameter tuning to see if we can improve the model. We can try a gradient boosting model. And we can maybe do feature engineering. We can run the model again using engineered features. We can create model explanations using PDP box plots. And we need to probably refactor the code. My ultimate goal is to build a Flask app for this project, and maybe build a Plotly app for this project too. So basically, today I'm going to be focused on just refactoring the code, because this is a whole lot of mess. As you can see here, it's kind of difficult to kind of make sense of what's going on, because I was just working on this code without organizing it. So today I'm going to just focus on cleaning up everything and refactoring the code. And next week I'm going to build I'm going to start building the Plotly app for this project, for life expectancy project. And uh, so next week I'm going to begin building the Flask app or the Plotly app. I think most likely I'm going to build a Plotly app because it's just easier to build a Plotly app for this project. And basically, the way the app is going to work is you will go on the website and you type in your information, and then this app will be able to tell you what your insurance premium should be, and it will be able to tell you what your lifetime value uh, to the insurance company is. And after we've built the app, we have a fully functioning app, then we can come back and improve the code. We can come back and try out these other things, improve the code, and any improvements we make to the code, we'll just update the app. So let's begin by refactoring the code. So this is the notebook I'm going to use the refactor, and of course I'm going to be copying from this side to refactor the code. So today's live stream, like every other live coding project, is going to be boring as usual. So I'll go ahead and run this. And I'm running this on a virtual environment. As you can see right here, it says insurance premium prediction ppm. So I'm running on a virtual environment. And let me go ahead and load the data. And basically, this allows us to see all the columns at once. That's what this line of code does. As you can see, this is what our data set looks like. It has a lot of columns. To be specific, it has 24 columns and it has 9,000 rows. And this is the profile report for this. I'm not going to do a profile report right now because profile report costs a lot of time to do. But I'm still gonna leave this code here. Once I'm all done with this code, I'm going to uncomment this or uncomment this to see. So how am I going to refactor this code? Let's see. I'll go ahead and delete this. All right. So I want to make a list of the things I want to get done with this refactor. I like to have a list. Oh, by the way, did you know in VS Code, when you click on this, it will create a new code cell, of course, and when you click on this, it will change it into a markdown. So I want to, let me see. So I definitely want this information there. Let me see. All right. So I'm going to build a function. I'm going to call it a data wrangling function. And I want this function to change insurance column to date time. I want this function to drop customer and effective to date. Let's see. Okay, I think I want to create another function for splitting the data. We are going to create a function for splitting the data. Alright, because right here I split this data, but I did this manually, but I don't want this to be manual. I want this to be in a function. That's the whole code refactoring step of like how do I clean up my code so it's like easier to work with. And I'm going to create another function for encoding the data. So let's see. Okay, I want to do that, and then let's see what else I want to do here. Um, okay, I want to use ordinal encoding to encode coverage column. So what did I do? Let me see. Okay. So this and this are both the exact same step. Alright. So that's the coverage column. So we are doing ordinal encoding for the so that's the education column, and then after that we are encoding the education column. All right, so let me see what other function do I want to build. So I want to create a function that rounds different things. So columns round. Okay, so this is gonna be a different function. I want to have a different function. So function for rounding various series. A lot of times I don't want to refactor my code because obviously it's not fun, but refactoring is an important process. Cleaning up your code is very, very important. And also next week when I start building the Plotly app or the Flask app, depending on which one I decide to work on, it will make it a whole lot easier to see what's going on with the code and be able to do things if the code is all cleaned up. All right, so now we are um, working with employment status. So here we are doing, this is where we created the encoding function, encoding data. I'm going to put ordinal encoding and one hot encoding in this one. So for this one, what we are doing is we are train encoded employment status dot value counts. So use one hot encoding to encode employment status. All right, so that's one hot encoding. After that, I want to, let me see. So I have a function for splitting the data. I have a function for wrangling the data. And after this, I want to change the column names. So I think I might do this in a different function. Yeah, I think I'm going to just create a different function. So I'm going to create a function for column names, and the columns I'm going to be changing will be employment status. Okay, so we are going to be changing employment status, train and test data. And we are going to be using one hot encoding to encode we are going to be encoding gender column. All right, so let's see what other encoding do we need to do. If we don't finish the encoding process this week, it's perfectly fine. Next week I will do this live project. I'll do this code again live, and we'll finish the encoding process next week. All right, so changing. So we need to change column names in gender column. After encoding, right? This is post encoding. So we need to also do location data. So one hot encoding, location data. So we had to do a whole lot of encoding for this project. So it's really nice. It would be nice to kind of have one function that does all of this. Like that would be dope. That would be like, yep, I've made it. Let's see, change. All right, so this is location column actually. All right, so we need to do one hot encoding for many different columns. So let me go ahead and copy this first. So one hot encoding for these columns. So these are columns we also need to do one hot encoding on, and we already have the code here to do all this. So this process is just putting it into a function. All right, so let's see what else do we need to do. So I got marital status, and then we probably need to change the names. This is just notes of what needs to be done next. Okay, so we need to create a so we also need to do one hot encoding on state column. So we also did one hot encoding on the state column. So we need to drop a few columns, response and renew. So I think I have, okay, response, renew offer. All right, so here in this function, I'm going to be dropping these columns. I went ahead and added it here. And this is why we do code refactoring, right? Because earlier in the notebook over here, I dropped some columns, and down here I dropped some columns more. It'd be much better to just have one function that drops all the columns at once that we need to drop. All right, so this is code for renaming the state column. So let's see. I think I'm going to put it here. We're gonna say rename state columns. All right. What else do we have here in our code? So I was planning on refactoring after this week, but I didn't. I'm just not getting to it. So let's see. Getting a preview. This is visualization. Let's say, do we want to create a function for visualization? Probably not. Actually, yeah, I think I'm going to create a function for visualization. So basically, I'll just pass in the x and y, and we get a, yeah, I think I'm going to create a function for visualization. So that's another function we need to create. All right. And then okay, so this is this is 3D. I think I only have one 3D, so I'm not going to create a function for it. We left Seaborn here because it costs a whole lot of time to do the Seaborn. So this is more visualizations. All right, so then now we are getting to building the model. All right, so this is where we got to building the model. I'm not going to create a function for all the models. I'm just gonna pick the best model and the top 10 features. And here we have two Y variables. So we have monthly premium auto and we have customer lifetime value. So we are going to be creating a we are going to be creating two models, one for monthly premium auto and one for customer lifetime value. All right, so this is our Y variables. So I'm going to create a function for defining Y variables. All right, so this, so I'm going to be dropping total claim amount here, but monthly premium auto and customer lifetime value is our Y values. So I think when I do the split, I'm going to define the Y variables and the X variables from the start, from the beginning. So when I do my split, so create a function for splitting the data and make sure to split into X and Y here for both X and for both Y variables. So here, yeah, so I'm going to, when I do my split here, I'm going to do a split for monthly premium auto and customer lifetime value. So this might end up being two different splits. I'm trying to see. Actually, I'm not gonna do the X and Y split over there. I'm gonna get here because I'm just gonna do training, and I'm just going to do train test validation split here at the beginning. So that's this function I'm going to create, and then down here I'll create another function for down here I'm going to create another function for splitting into X and Y. I think that's how I'm going to break it up, because I'm thinking, on a high level, from a high level perspective, how do I want this code to be organized? And this is exploratory data analysis and wrangling. And here it's going to be building the models. If I can type today. So function to split X data and Y data for both Y variables. So I'm going to create another function here for splitting the data. And then I'll make sure to here I'll make sure to drop Y variables from X data. I'm just adding a note to myself so I don't forget. So that's what we are going to do. And then I think I want to create a function for the baseline. Yeah, I think I want to do that. So, by the way, tab moves your cursor forward. Shift tab moves it backwards. I know it's the small things that matter the most, right? So I want to create another function for baseline model. All right, so I want to create a function for baseline model. I'm not going to work with the linear regression model. Like the whole point of beginning with a linear regression model was kind of have something to compare with, kind of see if the model is going to improve. So I believe the mean absolute error from our linear regression model was 5 point. If I can get this right. Very. I hate the way this jumps around sometimes. Let me make sure I'm going to save this. So that's the baseline. So the linear regression mean absolute error was 5.1, and the linear regression was 5.1, and then let's see, for the random forest model had the best one. So this is a random forest regressor, and the mean absolute error was 4.6. So I'm not going to do the linear regression model, the random forest model, like all these other models. I'm just going to pick the best model that I created, and that's what I'm going to be working with. So I'm only going to have one model in this refactored code. I could create a pipeline that does the encoding and then also do the modeling at the same time. But I don't want to create a pipeline because I want to keep this separate. I want to make it easier to see that, hey, these are the things I encoded and these are the names that I changed. I changed the names of the columns and this is the model. So I'm going to keep it separate. So I think I'll just create a function for the random forest model. Unless there's a better model down here. Let me see. So this is the random forest regressor. Let me see. I'm not going to include the hyperparameter tuning process. So this was the final model that I did. It has like a 4.3. So the regular random forest model is good. So I'm going to create a function for random forest regressor model. So that's the next function we are going to create. And then let's see. I don't think the gradient, the gradient boosting model wasn't any better. Alright, so I think I want to create a function for, okay, I already have a function for the Shapley plot. So here, just bring the function for Shapley plot over. All right, and then now we move on to customer lifetime value. And when it comes to customer lifetime value, we're basically going to be using the same thing that we used above. And so this is the process again. Here we are going to, I need to remind myself. So function for random forest model, let's see. I'm going to be, so I want to do function to split X data and Y data. X data is only the top 10 features. Drop everything else. So I'm only going to be using 10 features in this code. And that's gonna come in very handy. So in the future, when I start building the Plotly app, it will make it easier because you only have to provide like 5 to 10 variables. So I'll probably do top 5 to 10. Why not? Based on the amount of refactoring that we have to do, I don't think we'll be able to finish everything today, which is fine. We'll finish this next week, like we'll finish the refactoring next week, and then begin the Shapley plots the week after. So basically, I'll try and do this every single week. So with customer lifetime value, what we are going to be doing is we already have a function for splitting the data. So we already have a Y target. We have already done that. We already have a function for getting the baseline, so we don't need to refactor that. So I'm just gonna do use existing function for new Y target. baseline, and this is why refactoring and putting things in functions is so much better, because right now I did all of this for the insurance premium, building the models for insurance premium, right? I did all of this for insurance premium. I did all of this for insurance premium variable. Now I can do the same thing again for customer lifetime value, and I'll just use the functions. I don't have to write a whole lot of code. And let's see, for baseline, for random forest model. So when we get to customer lifetime value, we don't even need to write any new code. Maybe just 1 or 2 lines of code, and we'll just reuse the functions that we've been building. All right. So I think that's what I'm gonna do, and then next week I want to continue refactoring and then start Plotly app. I just think working with building the app using Plotly is going to be easier and faster than using Flask. But we'll see how it goes. It's gonna be exciting though. And after, like I said, after building the Plotly app, then come back and try improving code or improving model, right? But we just want to get the app going. So with that being said, this is good. This is a good place to be. I now have a clear idea of what I'm going to be doing. So I like to make lists and notes like this for myself before I start coding, so I kind of know what I'm doing. Like if you just jump in and start coding, you get lost and you be like, what am I supposed to be doing? Like you mess things up. So it's good to be organized by having this kind of note for yourself. So with that being said, let's go ahead and create this function to begin, right? I'm gonna put this in actually I can go ahead and I'm trying to think, how should I do this? I'll go ahead and copy this so I know exactly what I'm working on. Let's see. I'm trying to select multiple lines. User shift alternative. There we go. If you press and hold shift alternative at the same time, it lets you select multiple lines. So let's just call it dev wrangling. And let's see what we need. So we are working with insurance premium column, right? So let's see here. So this is our insurance premium column. So what we did was insurance activation date is equal to pd dot to date time, insurance effective to date. And okay, so this is the code. So here what we do is we provide the I'm trying to think the best way to do. I want to provide this. Actually, I don't think this is necessary because I remember, if I remember correctly, effective to date, we ended up dropping effective to date. Let me see. Yeah, so I don't want to write. I don't want to write redundant code. Just no point in like writing redundant code. So here, if I go ahead, let me go ahead and change this real quick so I won't forget. I don't want to write redundant code. That's the whole point of refactoring. So change insurance activation date. But this step may not be necessary though. So if I go ahead and do, let's go ahead and do insurance.head as it is right now. All right, so we are interested in activation date. So this is effective to date. All right, and then oh, okay. So in this process right here, in this process, I just created a new column called activation date. And in this new column called activation date, we basically changed the column called effective to date to date time, and we stored it in this column called activation date. That's what's going on in this code because I was confused for a second. I was like, this doesn't make any sense. All right, so I don't think we need to do this because we are going to end up dropping it anyway. So if you are going to drop it, let me see. I'm trying to understand my own code. Okay, so I ended up dropping it here because I created a new column called activation date that effectively takes the information in this column and puts it in this column. So after that, I have redundant information, and I needed to drop this. That makes sense. So that makes a whole lot of sense now, because at first I was like, okay. All right. Now I'm beginning to understand my own code. For a second there I was lost. I was like, what did I do? All right. So I want to make sure this list stays updated. So change insurance effective to date. All right. So now I have a better idea of what I need to be doing. All right. So I need to. So basically, I'm going to provide a data frame, right? That's gonna be my parameter. So I'm gonna call it data frame. And with this data frame, I'm basically going to copy this code here. I don't like the way this looks in VS Code. I think I'm gonna switch to Jupyter Lab. I'm going to switch to Jupyter Lab. Just give me a second. I don't like the way this looks. I don't like the way it looks in VS Code. Give me a second. Let me see. I don't know if I can launch Jupyter Lab from here. I didn't think so. All right. Give me Anaconda prompt. Anaconda. There we go. All right, and all right, so give me Jupyter Lab. All right, so we are in Jupyter Lab now. I'll go ahead and close this and close this. Let's go to Jupyter Lab. All right, so now I'm working in Jupyter Lab. I like the way things look in Jupyter Lab a little bit better because it's not like, it doesn't look weird. And I'm in the right kernel. As you can see here, I'm using the ppm1. So let's go ahead and run this. The reason why I like VS Code over Jupyter Lab is because VS Code has autocomplete. Jupyter Lab has autocompletes too, but it's not as intuitive as VS Code. If I was writing brand new code where I need a lot of autocomplete, then I might use VS Code. But since I'm just doing copy pasting, I'm using Jupyter Lab. I'm gonna leave this as it is. This stays here. And I'm gonna run this again so I have an updated view. All right, so as you can see, the function looks a whole lot better here in Jupyter Lab than VS Code. All right, so I'm just replace this with I'll replace this in this function. Let me do control plus plus to make it easier to see. So control plus plus. Hopefully you all can see this easily. Alright, so I'm gonna change this to data frame, and then change this to data frame. Okay, so that's one part of the function, right? If I can get to this. So I wanted to, in this, I wanted to change effective to date to date time. I've done that. And then I want to drop the columns I don't need. Okay, so that's changing it, and now I need to drop the columns. So alright, so now I'm just gonna replace insurance with data frame. And the columns I'm going to drop is customer, effective to date, renew offer, and response. So I'm just gonna make sure those columns actually exist. So we have customer, we have effective to date, we have renew offer type, and then response. There should be a column called response. There we go. Alright, so I'm just gonna drop these columns and I'm gonna add it to this list. And of course I can do it like this. And then this column is called renew offer type. Maybe renew offer type will help us in making predictions when it comes to the customer lifetime value. Let's see. Oh, the only another downside to Jupyter Lab is that it doesn't show visualizations. Yeah, so with Jupyter Lab, there's a little bit of problem with visualizations, but I don't think we're gonna get to this part of the code today anyways. I'm just gonna leave this here. Yeah, so with Jupyter Lab, there's a whole lot of problems with like visualizations, so that's why sometimes I use Jupyter Notebook, sometimes I use VS Code, depending on what I'm working on and depending on what I need. Right now I just need something that's not, I don't know, I don't like the interface for VS Code. But when you have visualizations, as you can see, they're not showing up in Jupyter Lab, which is not cool. So this is the future importances for renew offer for insurance premium for customer lifetime value. I was trying to see if renew offer type could potentially be a big factor, and I don't see renew offer type. That's something I didn't consider before. The first time I ran this model, I did not include renew offer type because I wasn't because it didn't even cross my mind that it could help with predicting the customer lifetime value, because the type of renewal a customer gets might determine their lifetime value. So I think that's something I'm going to add here. And that's something I'm going to add to this. So here I'm going to make a note to myself, include renew alpha type column because it might help predict customer lifetime value. So I'm not going to delete it here. I'm not going to delete it here. I'm not going to drop this column. I'm gonna leave it there. So since I'm not dropping it, I'm going to remove it from here. And these are only columns we are going to drop. Alright, so basically this is a very simple function. I'm basically going to change one column. I'm basically going to change one column from object to date time. And then after that, I'm going to drop the columns that I don't think I'm going to need. All right, so let's go ahead and run this and then see if we have, let's see if the function works, right? So basically what I'm going to do now is I'm going to let me see, how did I do this over here? Did I use the same one? All right, so I'm just gonna do insurance is equal to, well, actually I think I'm gonna have to use the dot apply function. Uh, let's try this first and see if it works. So wrangle, and here I'm gonna pass in insurance in the distance. Oh, I need to make sure I return something. I'm going to return the data frame. So basically it's going to return whatever data frame I pass in here. And here I'm going to pass in the insurance. I'll call it insurance 2 for now, just for clarification. So I'm going to pass in the insurance here as a data frame, and let's see if this works. If it doesn't, I'm going to try a different method. Now let's do insurance 2.head. Yeah, so I figured this might happen. Um, mm, and let's do this because I want the result of this to be all right. So it worked. So this worked right here. So when I just when I just did data frame, when I just use data frame here to do this and be like return data, it gave me none. But when I got a copy of it, so getting a copy of it makes it easier to return the data frame from a function. So let's see if our this one works. So let's see. I think it works. So we have a new column called activation date, like we wanted, and the columns customer, effective to date, and response has been dropped. As you can see, customer, effective to date, response has been dropped. This is the original data. At the beginning, we have customer and we have response, and we no longer have customer and response. So with just one function, we were able to achieve this. So that's good. Let's keep refactoring this code. Let's keep building functions. Let me go ahead and delete this. Actually, I wanted to cut this. I'll leave it for now. Alright, so the next function that we are going to be building is, so we want to create a function for splitting the data. Not a problem. So if we scroll down here, this is the code that we use to split the data. And I'm just going to call it def split data. And I don't know what parameters I'm going to need yet, but I know this is the code. Alright, so oops, should have done this before changing to, oh, it's fine. So for this function, we want to do from sklearn the model selection import trend test split. Do I have scikit-learn in this environment? I believe I do so. Do I need to import it first? So you can always look at your pip file to see what you have. So here in my pip file, as you can see, I have scikit-learn, so I'm good. So we want to import trend test split, and we want to do our training and our test data. It's equal to this, and we want our return function. We want to return our training, validation, test, and validation data. So that's the data we want to return. Alright, so here what we are splitting is the data. We are splitting the data. And here what we need to pass in is what the data frame is. We want to pass in the data frame that we are going to split. And we're basically going to use this code again. All right. Now you might be thinking, why don't I just create one function for everything? Well, first of all, it's better to create a function that does a specific task instead of creating a function that does so many different things that it will get confusing. And also, if you create a function that does a specific task, it just makes it easier to reuse that function over and over again. So this is, we want to return our training, test, and validation data. And I think this looks good to me. So let's go ahead and run this. And then let me see here. So we want is equal to, what did we call our function? We call our function split data. It's equal to split data. And we want to pass in insurance too, right? So we want to pass in insurance too. And let's go ahead and run this. Oh, by the way, in Jupyter Lab, if you press alternative and press enter, it will run the current code cell and create a new code cell below it. I should probably do a video that details different shortcuts you could use in Jupyter Lab. So now let's see if it works. Let's do train.head, and it worked perfectly. This is beautiful. So let's do test.head, and let's do validation.head. All right, everything worked, and let's just do one last sanity check. If we do insurance 2 dot shape, so as you can see, our insurance 2 column has 9,000 rows, but then if we do train dot shape, it has 6,000 rows, and we can do test dot shape, about 1,300 rows, and then we can do val dot shape, about 1,100 rows. So as you can see right here, our function for splitting our data into training and test data sets works beautifully. All right, so we got that, and let's see what's the next function we want to create. So I can go ahead and delete this from this. That's redundant. Let's see. So we want to create a function for encoding the data. So this function is going to be long, and it's going to take us some time to create it. So it's going to be a fun challenge. Let's begin. So let's create a function for encoding the data, shall we? All right. And Actually, what if, oh, by the way, if you just click on a code cell and all right, so let's call it DEF. Oh, I was saying something. If you click on something like this and click on M on your keyboard, it turns it into a markdown. If you click on code, it goes back into being a code. So let's call it DEF encode. Why not? Here I suspect I just need to pass in my data frame, and we are going to do data is equal to data frame dot copy, and we are going to begin encoding. So we are going to import category encoders as CE, and later in this notebook I end up using one hot encoding. So let's go ahead and import that too. And I already have category encoders in my environment, so I'm okay. Okay, so import category encoders as CE. All right, I see. That's all I need. One hot encoding does. Okay. All right, so we need to create a coverage dictionary. And again, how do I want to do this? Let me see. It's equal to this. All right. So this is our coverage dictionary that we're going to be using. Let's define our category encoder. And this is specifically for so we are doing ordinal encoding to encode coverage column. I want to make it clear because we are going to do a lot of encoding in this function. So I want to be specific which column I'm currently working on, so I don't get confused, and next time when I come back to this code I don't get confused. And also if you look in my codes, you see that I have a lot of comments, and the reason why I have a lot of comments in my code is so that when I come back to it like times like this, I won't get confused like, what did I do? Why did I do this? So we have so right now we are working specifically for the coverage column, and we are using ordinal encoder. CE is from here, and the columns is coverage, and the mapping is coverage dictionary. Okay, this makes sense now. So CE dot ordinary encoder, the columns we are going to be working with the coverage, and the mapping dictionary we are going to be using is this mapping dictionary right here. Oops. I meant to do save. All right. And actually, I'll just go ahead and I'll go ahead and commit my message. Git commit message code refactoring. All right. Git push. All right, let me go here and refresh. Whenever I push something to GitHub, I actually don't, let's see. Yeah, so whenever I push something to GitHub, I don't just push to GitHub and be like, I'm done. I actually go to GitHub, refresh the page, and verify that it was pushed, because I've had problems before in the past where like I push to the wrong repo. And whenever I refresh the page, my changes are not there. I'm like, whoa, like what happened? All right, so the changes are there. Let's go ahead and keep coding. It's good to periodically put your code on GitHub just in case your computer crashes in the middle of a live stream. And yes, that has happened to me before too. All right, so let's see. So now, okay. All right, so it looks like I'm going to have to provide different inputs here. Oh, also, the reason one of the other reasons to do a function like this is so that in the future, if I wanted to apply this, if I wanted to do this for, oh my gosh, what am I thinking? If I wanted to do this for the validation data set, I don't have to retype all this code because I already have a function. I can just call the function and pass in the data. Actually, I think I'm going to repeat this step, but also do it for the validation data because I like to do this. But here I'm going to do val and val. All right. So let me see here. So I have train encoded. It's equal to coverage dot encoded dot fit transform train, test, and validation. All right. So let me see real quick. So this is not the appropriate thing to provide. I'm going to have, I already have train test, validation test, data set. So here I'm going to provide the train data, test data, and I provide the validation data. All right, and here I'm going to do train is equal to train data dot copy. I want to create a copy of it. I'm gonna do test data. I'm gonna do just test. It's equal to test data dot copy. And then I'm gonna do validation is equal to val data dot copy. All right. So now I'm gonna be using this train test and validation down here, and I'm going to start the encoded thing and the new in this new variable. Alright, so ordinary encoding for the coverage column is done. So now let's move on to, actually I can go ahead and run this real quick just to verify that it works. And once we verify that it works, we can go ahead and add more columns to our encoding function. Oh, I need to return something. I keep forgetting to do that. So I'm going to return train encoded, test encoded, and val encoded. And of course, I could have done this with a pipeline, like I said. But it's so much easier and cleaner to do it like this if you are doing multiple encoding for multiple columns. It's easier and cleaner to do it like this than using a pipeline. But if you're just doing simple imputer for like 1 or 2 columns, or doing encoding for 1 or 2 columns, then yeah, scikit-learn pipeline will do the job equally fine. So you just have to decide for yourself which way is gonna be easier and cleaner to work with, right? So let's go ahead and run this. So let's go ahead and run this. We want to equal to encode. And here I am train test val. So basically here I have to provide the training data, the test data, and the validation data. And this is my training data, my test data, and my validation data. That's what I'm providing right here. And of course, if you have any questions about this, just let me know in the comment section. You can let me know in the super chat. You can let me know in the chat, or you can let me know in the comment section below. So we have a little bit of problem, which is fine. See, this is what I'm saying. It's good to it is good to run your code as you're working on it and make sure it works before you add more stuff. So I want to see what the problem is. Let's see. Oh, after adding this right here, I didn't run the code cell again. So now let's do train encoded dot head, and we were encoding the coverage column. So as you can see, it worked beautifully, right? So in our original data, if we go back, if we on the original data, we have extended, basic, right? So as you can, as I don't know if you know this, but when you're working with models like random forest model, it can only understand numbers. It doesn't understand text. That is why we have to do a whole lot of encoding to change this text into numbers. And Yeah, so basically our this thing works, right? So we've been able to change this text extended, basic into numbers. As you can see right here, our train encoded dot head data has been encoded. We can do validation and look at the validation data. As you can see, extended has been changed to 2, and we can look at test. It's going to change as well, and here they extended as 2 and premium as 3. Or should I have done extended as 3 and then premium as 2? I'll look into that. But so our now that we know that our function works, we can go ahead and add more stuff to it. We can go ahead and add more stuff to it. Like I said earlier, today's video is just refactoring code, while this video and next week's video is going to be just refactoring, really, because there's a lot of code here that needs to be refactored. So now let's do let's do the education column, right? So here, let me see. All right. All right, so and now we need to do this for the test and also for the validation. So we just change to val and val. All right. So basically here we are combining college and bachelor's into one data type. And this is not gonna change much. I'm not going to return this, but rather I'm going to go ahead and do this. And let's see. So I want this. So I like to keep my code clean. Let's put this on the next column over. All right. All right. So here we are replacing college with bachelor. All right, and this is just the dictionary for the education column. All right, and high school or below, bachelor, masters, doctorate, and we are creating an encoder for the education column. All right, and to make sure I'm keeping track of myself here. All right. So this is education encoder, and so this is our training encoder for the ordinary encoder. We are doing the same thing here. Mm-mm-mm. Wait, what? Let me see. So here I'm replacing college with bachelor, and the training test and validation data. Um, I don't need this. I've already done this transformation. Now I'm gonna call this validation, and I'm gonna call this validation. All right. So I want to make sure I'm on. I'm not losing myself here. All right. So this is for the coverage column, and this is encoding the education column. This is where I'm combining college and bachelor into one data type, and I'm doing that on the training data, the test data, and the validation data. Okay, and then I have a dictionary. I have an encoder, and the columns will be education, and this is the mapping dictionary for it, and then this is how I'm going to do the transformation. All right, that looks good. I'm gonna run it and run this code cells below again, and just make sure everything's working. So after I finish each encoding, I'm going to run the function and just make sure it's working. Sanity check, right? So let's see education. All right, so education has been changed to 11221. Interesting. So the coverage column has that's interesting. I didn't think about that in a function. See, the way you write code like this, it's a little bit different from the way you write code in a function. So, hmm. So, in order for the code to carry over, right? In order for the transformations I did here on this encoder to carry over to this, I need to use the same variable names, because when I did this, I basically reassigned this variable from coverage column to education column. That is why when I run this code the second time, the education column changed, but the coverage column went back to how it was before. So let's see. What I need to do is um, or maybe yeah, I think this is what I'm going to need to do. I'm gonna have to do train encoded here. And the reason why I'm using train encoded instead of train is because I want the transformation that was applied to this column to be carried over here, so that when I run this code, education column won't change and will change, and the next one won't change. Like, I want to get results for this column and this column basically. So I'm going to carry this over here. I think that should solve my problem. So basically this transformation will be happening to this data set. This transformation will be happening to the data set, and then this data set is going to be updated. Let's go ahead and save, run this, and run this. Boom, it worked. Alright, so our coverage column and education column has been updated. And let's see here. Bachelor, college, that's for the validation. Let's look at the validation. Let's look at validation data. Alright, so that looks good to me. So you can also do here validation.head, and kind of see we have college, bachelor, college. So this makes sense that they are ranked too, because I combined college and bachelor into the same thing. So this makes perfect sense, because here I said I want college to be called bachelor. I want to replace college with bachelor, and here I said bachelor to be 2. That is why college and bachelor here have the value 2. So everything is working as expected. And I think this is going to be it for this week. If you have any questions at all, let me know in the comment section. I'm going to be back again next week. And next week, we are going to continue with refactoring this code, and we are going to continue with encoding. Like I said in this video, this data set has a lot of things to be encoded. So let me go ahead and add this. So get add, get commit, message, encoding for education and coverage column. Git push. You're supposed to do git push main master. Git push master or something like that. To git push origin master to specify the branch you're pushing to. But in this situation, this is perfectly fine because I only have one branch. Finish encoding for the education coverage column. All right. So that's basically it for this week's video, this week's live stream. I'm gonna try to keep this live streams to 2 to 3 hours. This week I started a little bit late, but starting next week I want to do live streams on Saturdays at 10:30 a.m. But of course, also sometimes stuff happens and I'm not able to make it, or stuff happens and I'm not able to start at 10:30 a.m. But just look forward to live coding with me on Saturdays at 10 a.m. or 10:30 a.m. That's it for this video. Thank you for watching, and I will talk to you next time. Bye.